All right, so when you have something like this and you have the scalar multiplication on the outside, you want to do that first, all right? So my goal is to get that x by itself, and that x is going to be a matrix. But first I want to distribute. And so since we're subtracting, you can just distribute the 2. You don't have to distribute the -2 necessarily, because you're actually going to add that whole matrix over. So I'm going to distribute that 2 first. 2 times 3, 2 times 5, 2 times -2, and 2 times 1. Over here, I'm going to distribute that 1/2. So 1/2 times 12, 1/2 times 6, 1/2 times 0, and 1/2 times 7. All right? So use your distribution first, just like you would if you were solving, all right? And then my goal, if I'm getting this x by itself, I need to add this matrix over. So I'm going to add it over here. Okay. It will cancel here. And then I'm just going to perform the addition. I'm going to say 6 plus 6, that's going to give me my 12. 3 plus 10, that will give me a 13. 0 plus -4. And then 7/2 plus 2, if you get a common denominator, 2 is just 4/2. So 7/2 plus 4/2 is just 11/2. Or if you did it in decimal form, 5.5. Okay. So that was probably the hardest one because you had fractions in there. But you are going to look at doing your distribution first and then doing your addition subtraction. All right. Or if there had been a variable in front of the x, you would have done that last actually. Multiplying matrices, this is different than scalar multiplication. Scalar multiplication is when you have one number on the outside of the matrix and you're multiplying every element in the matrix by that number on the outside. Matrix multiplication is when you're taking 2 matrices and multiplying them. And so it's done a little bit differently. Some of the reasons they do it, they give the example of the amount of data that, like the NFL, if you've ever watched, especially baseball, I think they're full of facts when they're talking. They talk a lot. But they always have a lot of information, and they keep track of a lot of information. And so matrices sometimes help in seeing that a little better. And so they use the example of football: field goals, touchdowns, extra points, and 2-point conversions. And then they have these exact values. A field goal obviously is 3, touchdowns 6, extra point 1, and conversions are 2. So they can do it by team, but then if they want to see, well, how many points did they earn across the board, or how many points did they earn for field goals, or how many points were earned altogether for field goals, or something like that, they can use these 2 pieces and multiply them to figure it out. And so a lot of times they'll have all of the information listed out because they do need to see it that way, but then they'll have some more details, and then they can just quickly do a multiplication and it will give them kind of a combined amount. All right. And so one of the reasons we use that is for purposes like this. Let's talk about the rules of multiplying matrices. Okay. The first thing I want to point out is the dimensions. Okay. And so if you look at this definition, it says, given these 2 matrices, A and B, the product A times B is some other matrix, right? And then you use the sum of the products, which we're gonna do that in a little more detail in a second. So let's look at just the dimensions piece of it. All right. For the dimensions, we have 2 matrices. What I want to point out is that, remember, your dimensions are rows by columns. Rows by columns. The rows are listed here, right? The rows and the columns here, and the columns and the rows here is what we're going to pay attention to. The first thing you want to check is, do my columns of my first matrix match the rows of my second? All right? That is a rule. The columns of your first matrix must match the rows of your second, or you cannot multiply them. All right? So the first thing you do is, can I multiply them? Because there are situations where you cannot multiply them, right? And so if I can't multiply them, I'm going to say undefined, unable to, you can't perform the operation. So the first thing that you're doing is, can I actually multiply these? And the way you're going to check is you're going to look at the column, the number of columns of your first compared to the rows of your second. They have to match, okay? So this tells you whether or not you can or cannot do the operation. So you can multiply by checking that, all right? Now, the rows of your first and the columns of your second is the dimensions of your answer, okay? So your answer will have the number of rows from your first and the number of columns from your second, all right? So first step is to check, can I multiply? The second one is to see what your answer is going to be, all right? So the first thing we're going to do is just decide, can I multiply them? So let's write out the dimensions. What are the dimensions of A? How many rows and how many columns? A is what?
2 rows.
2 by 2, all right? What about B? 2 by 3, all right? And then C is going to be 3 by 3, all right? So they just want to know, can you multiply them? Can you multiply AB? Well, the columns of A are 2. The rows of B are 2. Yes, you can multiply those, all right? What will my answer be? Well, my answer is going to be the rows of A, 2, by the columns of B. That will be my answer. It will be a 2 by 3. Let's look at the next one, AC. A has 2 columns. C has 3 rows. We cannot multiply these. This is undefined. All right, the columns of A do not match the rows of C. All right, let's look at B and C. The columns of B are 3. The rows of C are 3. Yes, I can multiply those. My answer will be the rows from B and the columns from C. All right. Now let's look at the last one. A was, can we multiply AB? D is saying, can I multiply BA? Normally, multiplication, order doesn't matter, right? So for scalar multiplication, it really doesn't matter which way you multiply, whether it's the matrix and the number or the number in the matrix, all right? Or if I'm just multiplying standard integers, 2 times 3 equals 3 times 2, right? We don't even have to care about it. That is not true for matrix multiplication. The number of columns in B are 3. The number of rows in A is 2. So while I could multiply A times B, I cannot multiply B times A. This guy here is going to be undefined. All right? So order matters with matrix. And order does matter with matrix. Your columns from your first have to match your rows from your second. All right? Now let's look at how we actually multiply. All right, so this right here is the rest of that definition. This actually tells me how to multiply, all right? And so we're going to multiply some of the products. You're going to start with the rows of your first, and you're going to multiply it by the column of your second, okay? And so I'm going to take A and multiply by E, and B and multiply by G, and I'm going to add those together, and that will be my first element. And then I'm going to stay on this same row and go to the next column. A times F plus B times H. That will be my next. When I run out of columns, I move on to the next row. And that will start my next row. So now I'm going to say C times E and D times G and add those. That will be my next element. Stay on this row and go to the next column. C times F, D times H, add those, and that will be my next element, all right? Which is why your columns have to match your rows. So you'll run out of elements, or they won't match up if they don't do that, okay? So let's look at multiplying A times B. The first thing we're going to do is say, can we multiply them? So what are my dimensions? Well, this is 2 by 3. This is 3 by 2. So I can multiply them, right? My inside dimensions match. My answer is going to be what? What is my answer going to be? What are the dimensions of my answer? A 2 by 2. All right. So let's multiply them. We're going to take the first one and we're going to multiply it by the second one. All right. So I'm going to start with my first row. All right. My first row and my first column. And I am going to create an answer here. And I leave it kind of big because I write it out for the first part. So I'm going to say 2 times 3 plus 4 times 5 plus 0 times 1. When I get to the bottom of that column, I am done with my first element, Then I'm going to use that same row, but I'm going to go to my next column. So now I'm going to go down this column here. And I'm going to say 2 times 4 plus 4 times 2 plus 0 times 0. And I am out of columns, so I'm going to move on to my next row. All right, so I'm going to move on to my next row. Now I'm going to take the second row, this one, and I'm going to do the same exact thing with the first column. So I'm going to say 1 times 3 plus 3 times 5 plus 5 times 1. All right. Now I'm going to do the same thing, and I'm going to go to the second column here. And I'm going to say 1 times 4 plus 3 times 2 plus 5 times 0. All right. So that's the setup. Once I'm done, I'm just simplifying basic multiplication and addition, okay? So my answer to A, B is going to be these sums. So this is 2 times 3 is 6. 4 times 5 is 20. 0 times 1 is 0. 6 plus 20 plus 0 is 26. That's my first element. So next one, 2 times 4 is 8. 4 times 2 is 8. 0 times 0 is 0. 8 plus 0 is 16. That is my first row. Second row, 1 times 3. 3 times 5. 5 times 1. 3 plus 15 plus 5 is 23. Next one, 1 and 4. 3 and 2. 5 and 0. 4, 6, and 0 are 10. This is my answer here. When you set this up, and I've set up the types of scores and the point value of the scores, when I do my matrix multiplication, I am getting the total points earned. So I'm able to look at it multiple ways. I can look at each of the teams and see how they're earning their points. Clearly, the Bears are getting lots of touchdowns, right? I can see where they're earning their points. All right, as a manager or as a coach, how does this help me? Well, if I'm not earning a lot of touchdowns, then I'm earning a lot of field goals. For those of you that are sports fans, why am I only getting to field goal range? Do I have an issue with getting it all the way down the field? Okay, so this kind of data is going to tell you some information when it's spread out like this. Okay, this is going to tell you overall, what points are we earning per game? All right. And so they can look at it both ways. They can look at it spread out. They can look at it like this to see a count versus a total. This could be a cost. Like say you're selling items. How many items of each did I sell could be going across. And then what did I sell them for could be going down. So not only are you getting a cumulative data of a number, but you're also getting a cumulative data of total dollars sold, okay? And so 2 ways to look at the same information. The multiplication helps you sum it up, all right? So for this first one, I'm going to look at my first row, 3 and 6. And I'm going to multiply each piece of this by the first column. So I did 3 times 3, that's what I got here, plus 6 times negative 5, right there. Okay, that's my first one. When I'm done going down, I'm going to stay on the same row, but I'm going to move to the next column. So I did 3 times negative 3 and 6 times negative 6. So that's where I got this. 3 times 3, 6 times negative 6, all right? I stay on this row until I run out of columns. I'm officially out of columns for this row, so now I'm going to move on to the next row, all right? Now I did the same thing. This row, the second row, times the first column. So now I did 6 times 3 and 6 times negative 5, which is how I got that down here. 6 times 3, 6 times negative 5. Same row again, so I'm going to stay on this row, and now I'm going to multiply by this column. 6 times negative 3, 6 times negative 6. Once I'm out of columns, I'm done with that row, and once I'm out of rows, I'm done. All right? Then I just did your basic algebra, your basic addition and subtraction, right? Order of operations. 3 times 3 is 9, 6 times negative 5 is negative 30. So 9 plus negative 30 is negative 21. Negative 3 is 9, 6 and negative 6, negative 36. Add those, negative 45. 6 and 3 is 18, 6 and negative 5 is negative 30. Add them, negative 12. Negative 18, negative 36, negative 54. Okay? So I checked, can I do it? Yes. My answer is a 2 by 2. My answer is a 2 by 2. All right? Over here, I checked 2 by 2, 2 by 3. Yes. My answer is going to be a 2 by 3. I started with this row. I did the first column, 2 and 5, 0 and negative 2. I did the second column, 2 and negative 6, 0 and 5. The third column, 2 and 3, 0 and negative 5. That's how I got this first row. I ran out of columns, so I moved on to my next row. 4 and 5 is what I'm using now. So 4 times this 5, 5 times negative 2. That's my first one. 4 times negative 6, 5 times 5. 4 times 3, 5 times negative 5. So that's how I got this. And then I just did the order of operations. Multiply, then add, which is what gave me this. All right, a multiplicative identity matrix. The main diagonals are 1, and everything else is zeros. So like if I have a 2 by 2 and I want the identity matrix for any 2 by 2, the diagonal from top left to bottom right will be 1s. Everything else will be zeros. If this had been a 6 by 6, which would be a huge matrix, but the entire diagonal would be 1s. Everything else will be zeros. It's called an identity matrix because you'll notice they did the multiplication. 3, negative 1, 8, and 12. And they multiplied by the identity matrix. And look at the answer. 3, negative 1, 8, and 12. Because if you multiply anything by the identity, like let's say your identity for multiplication is 1. Multiply anything by 1, what do you get? Well, you get what you started with, okay? This is the same that's true for the identity matrix. When you multiply something by its identity matrix, you will get what you started with, okay? You will get what you started with. And it doesn't matter for identity what order you multiply in. You'll notice they switched the order. They still got the same matrix, okay? So it's like multiplying by 1. Identity matrix is like multiplying by 1, okay? And so anytime you multiply a matrix by an identity, you're going to get the same matrix that you started with, all right?